Hello, welcome to your OCHEM 2 course. Today we're going to be looking at the production of Stilbene dibromide from Stilbene. This is the reaction scheme of the whole pathway that we're going to be making. We are in this reaction that corresponds to chapter 28 of your book. The preparation of Stilbene dibromide from Stilbene. So we have to remember that regularly this reaction is carried out with bromine, liquid bromine. But this may be fatal if inhaled. It's highly toxic by inhalation, ingestion, or skin contact. It also can cause severe burns. Therefore, we're going to use an alternative that it's not bromine. Using the pyridinium hydrobromide perbromide is a reagent that is still very dangerous, but can be handled a little more easily because it is a solid. It is extremely hygroscopic, and it will absorb the moisture rapidly from the air and become sticky, so it is important to keep it very well capped. In this reaction mechanism, we see the interconversion of the pyridinium hydrobromide perbromide into bromine, diatomic bromine, which is an in situ preparation of reactive bromine. The mechanism is as follows. So the double bond is going to attack a bromine ion, and the bromine is going to attack the double bond, making the bromonium ion, which is positively charged, and a negatively charged bromine anion. So this species, the bromonium cation, is actually very unstable. So the anion is going to attack either side of the bromonium ion, and it's going to form the dibromide species. So there is really not a selectivity here because the molecule is symmetrical. So the bromine ion can attack either side of the of what used to be the double bond, making different types of enantiomers. Yeah, so here we see the appearance of the bromonium ion in the third dimension. And as I mentioned, both attacks can work and will happen. This is actually going to make a very complicated racemic mixture. We came from both cis and trans stilbene, and both of them are susceptible to the attack of the bromine. So we're going to actually form the RR, the SS, and the meso compound. And all of these stereoisomers can be converted into the diphenylacetylene in the next class, so it's not really important to purify them. This is the experimental procedure for the preparation of Stilbene dibromide. We're going to mix 40 ml of acetic acid, 2 grams of Stilbene, 4 grams of pyridinium hydrobromide perbromide, and we're going to heat this on a hot plate. We're going to cool the reaction in an ice bath to form the crystals, collect the product by vacuum filtration, and then on the filter paper in a Buchner funnel, we're going to maintain the vacuum, and we're going to wash the crystals with a minimum volume of ice-cold mixture of 1:1 water methanol. If the solution is too warm, some of your product will dissolve and be lost, so mind this and keep it very cold. If washed with too much water methanol solution, some of your product would dissolve and be lost too, so it needs to be just the right amount. Calculate the yield and report it to the TA. We can select between doing thin layer chromatography or not. This is going to be your TA's choice. Hexanes can be used as a TLC element. We will not measure the melting point. We will not attempt to do recrystallization, since all three isomers are as equally useful for the next reaction. There are hazards in this exercise, which could be extremely hazardous handling of the pyridinium reagent. We will use glacial acetic acid, which is extremely acidic, and methanol, which is present in alcohol beverages, but it's not well to consume it. So the contents of these reactions are dangerous. The flask has to be heated, which means if held by hand, one could develop a thermal burn or not grip the flask firmly enough for safety. The best thing to do is to attach 2-prong clamps firmly and hold the flask from the clamp. The clamp and flask can also be tied to a ring stand when not held by hand. At the end, we're going to do IR and NMR spectroscopy of your compound. Remember to save your product since it's going to be the starting material for the next session.